Okay, since I ran out of time on the last one, I figured I might as well do the example here as opposed to just leave it. So what you would do then in the x direction, you would say x. So m1v1 initial x plus m2v2 initial x is equal to m1v1 final x plus m2v2 final x. Well, initially the second one isn't moving, so that goes to 0. And we're trying to solve for v2fx. So bring the other term over, m1v1, whoops, that's an initial, x, and minus m1v1 final x equals m2v2 final x. So look up here, m1v1 final x is really the adjacent side of this triangle. So it's really just m1 final cos theta. Okay? And m1 initial x is really just m1 initial because it's totally going in the x direction. So we would write this as m1v1 initial minus m1v1 final, and we said it was cos theta. And then we would divide by m2 because we're trying to find v2 final x. And so now fill in your values. So we said m1 was 5 kilograms, and we said v1 initial was 4 meters per second, and m1 is 5 kilograms, v2 initial 2 meters per second, and it's cos of 30 degrees divided by 8 kilograms. So that's 20. Cos of 30 is 0.866. Multiply that by 10. So 8.66, and then you're taking that away from 20 on the top, and you're dividing by 8. So you get a V2 final x of 1.417, let's say 5 meters per second. And now we're going to do the y. So m1v1 initial y plus m2v2 initial y is equal to m1v1 final y plus m2v2 final y. So we take a look, and in the y direction initially, ball 1 isn't moving in the y. So it actually goes to 0, and ball 2 is not moving at all initially, so it also goes to 0. So both of these terms disappear. So you're left with 0 equals m1v1 final y. So look up here, here's the v1 final y. It's the opposite side, so it's equal to v1 final sine theta. So down here, v1 final sine theta plus m2 v2 final y. Solving for v2 final y. So negative m1 v1 final sine theta over m2. So negative 5 kilograms. The v1 final was 2 meters per second. Sine of 30, I think it was, yeah, sine of 30 divided by 8 kilograms. So 5 on the top, half of 30, half of 2 is 1, so negative 5 over 8. So negative 0.625 meters per second. And the negative just means the opposite direction to number 1. In this case, number 1 was going up, so the negative means going down. So now we have these two components that I was drawing for you just before the video ended. The x component is 1.4175 meters per second. The y component is 0.625 meters per second. And so now you're going to square them and add them together and take the square root and get your VF. And so when you do, VF equals, so squared plus, unfortunately I cleared that other number, so this is going to be rounded, 1.4175 squared. Take the square root, so it's 1.549, I'm going to say 2 meters per second, and then add an angle of, and so now do your angle, 0.625 divided by 1.4175 second function tan. You get an angle of 23.79 degrees. And which way is it? It's counterclockwise. Now, I don't know if I said east up here, did I? No, I didn't put an east or a west, so we would just say it's clockwise CW original, meaning clockwise the original direction. And this would be your final answer. Okay, so I have a couple of them that follow this for you to try. They would be on page 509. Page 509. Numbers, too bad I can't see. Numbers 35, 36, and 37. Okay? And so they're similar to this. So draw your diagram. Break up the one you know into its x and y components because you can get those. And then use conservation of momentum in the x and then conservation of momentum in the y to get the components of the one you don't know. And then you do Pythagorean theorem and tan to get the angle, just like we were doing with forces. Okay? Very good.